Let's move on to Article 285, surge protection device. I really believe this is an area that the industry is not taking an advantage of. I really believe, particularly in areas that have a lot of lightning or almost any building, because you have loads that are turning on, turning off, you have transients, that you really should have surge protection at the service. As a matter of fact, the 2014 code added a requirement for surge protection on emergency branch circuits. I think that's 700.9. Ryan, let me know what's the code rule on emergency circuits. I think it's 700.9. You have to have surge protection for emergency branch circuit panel boards. So we're going to talk about what is surge protection, but electrical contractors should be considered. 700.88, okay, is the new rule on surge protection. So it's the first time the code is requiring surge protection. And think about it. If surge protection is required for an emergency system, don't you care about your family? I mean, aren't you more important than anybody else? So, but surge protection is to protect equipment. Let's take a look at the rule here. What's going on here? Well, see, you know, voltage is really not pure sinusoidal when it's a perfect. It clicks on and clicks off. There's a lot of different things that are taking place. A lightning event outside could cause this high transient voltage going on, okay? Capacitors kicking on, capacitor going on. This is power quality. I have a DVD and I have a textbook that I wrote on power quality. As you kind of get your theory, you kind of get your code, you get your grounding and bonding, you get that inside there, you get your electrical calculations. By the time you get the power quality, that really requires you to understand a lot of stuff before you get there. So don't think of going to power quality until you get all these fundamentals. But this is important to understand as well. So let's go back to some power quality here. So now we have these voltage spikes that's taken, and transients. Now, it's not only produced by outside sources, it can produce by the inside the building itself. When a load gets turned on, it will cause an instantaneous slight dip in the voltage. And then when the load is turned off, a large inductive load, when it's turned off, it all becomes what? It becomes a generator. It kind of like, it shoots the energy back up. So take a look here. So loads that are turning on or off in a building are causing all transients, or causing all these transients. So outside the building, you have transients. Inside the building, you have transients. And now a surge protection device is something that is designed to protect the equipment from these transients. And let's take a look at this graphic here. Let's just assume that you had the 680 volt transient on the primary side of a transformer. It transformed to 340 volts transient. We have a 120 volt load. It can only take so many of these hits. It's going to be etching the chips. It's going to be slowly working in there. And ultimately what it's going to do, it's going to destroy that equipment because of the transients. So let's go into the scope of 285.1. This article covers the installation and connection required for permanently installed surge protection devices. Not something you buy in a power strip. Because again, we've been kind of working this out. The code is an installation standard. If you are installing a surge protection permanently and you're putting permanent wiring in there, well, that's a code. But if you're buying something that's cord and plug connected, well, that's not part of the code. So the code is making it clear in 285.1 that it's dealing with permanently installed surge protection devices. By the way, this used to be called surge arresters, TVSS. And then it was called transient voltage surge protection devices, TVSS, and now it's called surge protection devices. So this industry has been moving around, and they've also changed the technology, which I'll talk about as we go along. 285.4, number of surge protection devices required. Now, I discussed this already previously, that if you had a 680 amp primary transient voltage, it transformed down to the secondary 340, you have a 120 volt load, well, then you'd end up wiping out that equipment. And the purpose of surge protection is to shunt that energy in some fashion that we would get the voltage to the equipment to be reasonable within the rating of the equipment. Now, what you're looking at in this graphic, even though philosophically it's kind of the concept is you have higher voltage and the equipment has a certain rating and you're doing something to kind of shunt that energy and clamp that voltage to the equipment, I'm kind of showing what is called RMS voltage. And Eric, why don't you say something that we have no clue what you're going to talk about how this is kind of working. Let me talk about the concept here. The concept is that if I can do some kind of device that could drop this voltage down so that the load connects in parallel to it, it will minimize the damage to it, because without this, it's going to be 340. But tell us about this voltage and sinusoidal a little bit there, how conceptually it's okay, but...
Well, okay, so a couple of slides back, you had a really nice looking sinusoid up there with lightning strikes in the back. We call that 120. But when we look at it, it's going from 0 up to some number and then down to 0, then down to another number and back up to 0. So that peak, those peaks are actually 169.
Even though the RMS voltage is 120.
Right. Average value or RMS value, effective value, it's 120 volts.
Hold on. That value is derived by that sine wave.
Right. And well, you square the sine, and then you take the mean of it, and then you take the square root. We think of that backwards, though. We call it RMS, so root mean square. So it's 120 volts effective, but the actual sinusoid is 169. So what that means, since the SPD is an instantaneous device, if the SPD were set at 140 volts, you couldn't even power a load because you have to allow 169.
So when I was using this example, I'm using RMS as examples.
Just a philosophical example.
Not only that, but this voltage right here, we can't predict what that voltage is because it's not even a sine wave.
Right.
So, I mean, I'm just saying, philosophically, you got higher voltage than the rating of the equipment gets damaged, and then 285, that 4 says, well, you need one for each of the ungrounded conductors. It kind of drives that voltage down, but these numbers in this example is kind of okay, but that's not exactly how it works in instantaneous values of transients.
Right.
Okay, and I'm going to go with that. Surge protection devices must be listed. Why? Well, because there's energy involved. It's trying to work. It's trying to do something. It's an electronic device that's absorbing energy and causing a clamping of the voltage. It has to have a short circuit current rating. Surge protection devices must be marked with the short circuit current rating and cannot be installed where the available fault exceeds that rating. And we talked about that in Article 100 definition of surge protection devices. There was a type 1 that's installed at the service. There's a type 2 that's installed on the load side of the service. But no matter what you do, it has to be suitable for the available fault. And we went back to 110.24 on calculating the available fault at the service equipment. I even gave you a link into mycolt.com to go to free stuff, go to the link on resources and download the spreadsheet. So, and then we talked about that 110.9, making sure that the equipment can interrupt the current of the available fault. 110.10, make sure it had the short circuit current rating or the withstand rating. So all this stuff comes together. We don't want the thing to blow up. So it has to have the short circuit current rating. Take a look at this phone photo right here. This is actually something that's on my property. I go to my house where I live now. I had a pole there, and all of a sudden I'm like, what the heck is that? There was a surge protection device that something happened. But see, this was the devices that were used years ago, that when you open a neutral, see, years ago, when you open the neutral on the surge protection device, if you open the neutral, then you had that voltage that went from 120, 120, and let's say it went to 160. Let's say this operated 160 volts continuously. Well, then that thing clamped, it caught on fire. So surge protection devices now are designed that if you open the neutral at the circuit or you open the neutral at the service and you got that changing in the voltage that takes place, the surge protection devices do not remain clamped continuously. They will know, okay, this thing is closed. Usually what they'll do is they'll have fuse protection inside there. It'll just wipe out the fuse protection. They will not catch on fire. They might not work again. And surge protection devices, you have indicating lights. You need to be checking these things, and you need to replace them as they need to be replaced, like any electronic device. Let's go to 285.11, the location. Where do you locate them? Can be located indoors or outdoors. Doesn't really matter. And I showed you that one example. You can see the pile of that surge protection sitting right there on the ground. Maybe I don't want to locate them inside. Or at least today they're made differently than the way they used to be. Routing of the conductors, 285.12. Surge protection conductors must not be any longer than necessary, and unnecessary bends must be avoided. Eric, why do I need to keep these conductor lengths short, and why do I need to avoid unnecessary bends?
Because the manufacturer tells you to do that. And these surge protective devices, I mean, these things are calculated and manufactured and engineered to the nth degree. But yeah, surge, in essence, a surge is extraordinarily high frequency. And so when you have bends and things like that, there's too much reactance and the devices won't work.
Okay, theory. You should understand exactly what Ryan, you changed your name, what your name is. Eric is talking about. You have to understand inductive reactance, frequency. Listen, every single thing we do, the code is trying to accommodate the physics of the reality. I mean, that's all it can do is to accommodate fires and making sure things are not going to get dangerous. So surge protection conductors need to be as short as possible. And you need to have unnecessary bends because of the high frequency. It's a transient. They're high frequency transients. Let's go on. 285.23, type 1 surge protection devices are on the line side of service equipment. Article 100 describes them. Type 1 surge protection device rated less than 1,000 volts and are listed to be installed on the line side of the service equipment. So you can put a type 1 on the line side of service equipment. All right, 285.24, type 2 surge protection devices. It has to do with feeder circuits. It's important that you don't forget Article 100 rules as it relates to surge protection devices, and that you read what is a type 2 surge protection. Ryan, would you go to 100 for me, surge protection, and what does it say read me type 1. We just covered that because that was at service. But right. I'm sorry, I should ask you sooner. Read me what type 1 surge protection says, 100.
That's a permanently connected surge protection device intended for installation between the secondary of the service transformer and the line side of the service disconnect overcurrent device.
Clearly, line side. Now read me type 2.
That would be a permanently connected SPD intended for installation on the load side of the service disconnect overcurrent device, including surge protection devices located at the branch panel.
Okay, so here we are. So what's the code on 285, say 24A? It says type 2 surge protections are listed to be installed on the load side of the service equipment. It's kind of very close to what 100 is talking about. So that's where you put it right there, load side service equipment. And you install it in accordance with the instructions. And since it's on the load side, it will have overcurrent protection. And you have to read the instructions as to what kind of overcurrent protection is required. When you go on the line side, there's no overcurrent protection. But it's a type 1 that's listed to be installed on the line side. Here's an example. Sometimes surge protection is built right in the panel on a circuit breaker like that. Connecting surge protection on the load side. It's a violation of 110.14a, having more than one conductor on the terminal. And that's a pretty common practice of people making mistakes. Not making mistakes, or violating that particular code rule. Something like that. I think we've seen that back in 110.14. All right, that is the end of Wiring and Protection DVD, Chapter 2 of the NEC. And I want to thank our team members here. We got Victor, Eric, Ryan, and Brian. And, of course, I got Mike Corbett hanging here on the left of me, and he's making all kinds of notes on how to make the graphics even better. And I want to thank you guys individually for watching this DVD. I know we didn't cover 220 because that's a whole other area, and 250 grounding and bonding. You can see we did the best we could. There's a lot of material there right there. Make sure you go back and you watch the DVD. Get your code book out. Make sure you highlight it, tab it, do all the things that we talked about. Make it personal to you. I even have little graphics here showing me. I even look right here, my little book right here. I made some little pictures right here so I can kind of remind myself as to what's going on. So, embrace it. Okay, we're going to be going to Chapter 3 on the next DVD. Have a great evening. God bless. Thank you.